In this second part of the question, we're again given the fact that the random variable y follows a normal distribution whose mean is 40 and whose standard variance is 3. So we now want to calculate or evaluate the probability that y is less than 40.5 or the probability that y lies between 42 and 44. So we can disaggregate the information. In other words, we can split this up. So this is the probability that y is less than 40.5 or the probability that 42 is less than y is less than 44. So the first bit, we can rewrite this properly as the probability that y lies between negative infinity and 40.5. And then we can use, once we see or means that we can invoke the addition rule and add the two different probabilities. So we have probability that y lies between 42 and 44. All right, so we have mathematized the probability statement that has been presented to us in a more explicit fashion, and then now we can diagrammatize the information so that it's sort of a little bit more concrete for us. So we're going to do a sketch of the normal distribution curve. So we identify the center as the mean, which is 40. And then we have 40.5 on this side. Identify that as 40.5. So to be less than 40.5, all of this area right here. And then 42 to 44. So we're going to have 42. Let's put that right here. That's 42, and then 44. Let's put that right there. So we want those two regions. Okay, and notice that the two regions are disjointed or discontinuous, or discontiguous, rather, and therefore we can add the areas in order to get the total probabilities. So where do we go from here? Again, we have two major strategies. We have a calculator strategy, and then we have a tabular strategy. So if you have access to a calculator, straight away you can sub that into your calculator and then get the probabilities and add them. So let's use a calculator strategy. So we would go to statistics, then we'll go to distribution. We would choose a normal distribution, N for normal. Then we choose normal cumulative distribution, and then we're going to have our lower, our upper, and then into the mean and the standard deviation. So for this one, we're going to use an arbitrarily small or arbitrarily large negative number. So I would use negative 1,000. Then the upper will be 40.5. Then the mean is going to be 40. And then the standard deviation is 3. So I use the Casio FX9850 GC Plus. And so if you will with me, you can do you can follow the routine on your own calculator. So I would go to statistics, distribution, normal, NCD. My lower is minus 1,000. My upper is 40.5. Sigma, standard deviation is 3. Mu for mean, that's 40. And then I execute. And so for the first part, I'm going to get 0.56618. So that makes sense because the area is more than half of the shaded region. So now we're going to do this. This part is going to be easier for us because we have a lower of 42 and an upper of 44. So we have the lower to be 42, the upper to be 44, the mean to be 40, standard deviation is 3, and then we exit and then we repeat. Lower 42, upper 44, sigma, standard deviation is 3, and mu is 40, and that will give us 0.16128. So we add, exit, go to run matrix, and then we add 0.56618 plus 0.16128, and we get 0.72746. We can leave it like that, but as I said before, we can rewrite our answer to 4 significant figures, or 3 significant figures. So and so we can, our final answer could be written as 0.7275 to 4 decimal places. And that is our first strategy. So we can continue by now applying a second strategy, which is going to be using a tabular method to evaluate the statistics. So in using a tabular method, we're going to be applying Z statistics rather than Y statistics in evaluating the probability. So let's keep this as our check, 0.7275, and then now let's look at we're going to apply the conversion formula. So we know that the conversion formula is that Z is equal to X minus mu over sigma. And let's do a sketch. So we have 40.5, then we have 42, and then we have 44. And then below, this is going to be 40.5 minus 40 over 3, and then this is going to be 42 minus 40 over 3, and then this will be 44 minus 40 over 3. So if we evaluate those for the corresponding Z statistic, this will be 0.5 over 3. So 0.5 divided by 3 will be 1 over 6. All right, so we can leave it as 0.5 over 3 for the time being. Okay. And then this will be 2 over 3. And this will be 4 over 3. So if we work this out, this is 1 over 6, which is roughly 0.17 to 2 decimal places. This is 0.67 to 2 decimal places. And then 4 over 3 will be 1.33 to 2 decimal places. So what we want is the following in terms of our Z scores. We're going to want the probability that Z is less than 0.17 plus the probability that Z, so let's write it like this. All right, let's write it over here. So our problem is the probability that Z is less than 0.17 plus the probability that Z lies between 0.67 and 1.33. So that's where we are at now. So let's focus on this, and then we'll focus on that bit. So let's erase this for the time being. All right, so the probability that Z is less than 0.17, we can go directly to our table. So we are going to look for, so we have Z there, we would go down to 0.1, and then we would go across to 0.07, and then we would just triangulate that way. So 0.1 row, 0.07 column, and then we should get 0.56749. So depending on the table that you use, it might have different degrees of accuracy. All right, so this gives me 0.56749. All right, so now let's focus on the second bit. So to get this area here, what I need to do is I need to find, so the probability that Z falls between 0.67 and 1.33. Notice how we can do it. We can find all of the area to the left of 1.33, and then find all of the area to the left of 0.67, and the difference will be the shaded region. So this is really equal to the probability that Z is smaller than 1.33 minus the probability that Z is smaller than 0.67. So you can convince yourself that that is reasonable geometrically. So the shaded area, once you see a shaded area, it's really the larger area minus the smaller area. The larger area occurs when we look at left of 1.33, the smaller area when we look at left of 0.67. So here we can apply the same approach and tabular method. We look for 1.3. So we would look at 1.3 and then 0.03. So 1.3, and then we go across to 0.03, we get 0.90824. So that's 0.90824. And then now we want to get 0.67. So this is with 0.6 and then 0.07. So if we do that, 0.6 and then go across the 0.07, we get 0.74857. So this will be 0.74857. So when we subtract those two areas, we're going to get 0.90824 minus 0.74857. That gives us 0.15967. All right. So we need to find the sum of these two to conclude our problem. So this means that we're looking for 0.56749 plus 0.15967. So we add that to 0.56749, and we get 0.72716. All right. So here to 3 decimal places, 0.727. So here there's a slight discrepancy once we move to 4 degrees of four significant figures. But I think because we are rounding here, we have 0.67 rather than 0.6 recurring. That will introduce a little bit of error, but not sufficient to cause us worry. So we see that our answer is roughly equal, but some error because of the rounding that's introduced in the problem. So ideally, if we're using the original values, then that will give us the accuracy that is required. But do be aware, once you're rounding the values, there will be introduced some error in our final solutions.